Hi, welcome. In this video, we will solve product of an array except self asked by companies like Bloomberg, Microsoft, Facebook, and Google. Now let's check out one more interesting problem. Product of array except self. So given an integer array nums, so this is my array nums 1, 2, 3, 4. Return an array answer such that the answer is equal to the product of all the elements of num except nums of I. So what is the meaning of this? So here you can see this is my array 1, 2, 3, 4. I need to find out the product of all the other elements except the number itself, right? So if I take the product of all the other numbers, that will be 4 into 3, 12, 12 into 2, 24. So that is the product 24 except 1. So if you can understand by this example, let's see if I'm not taking 3 and if I'm taking product of all the other elements, that will be 2 into 1, 2 in the prefix part and 4 only in the suffix. So 4 into 2, that will be 8, and that's why the product is 8. Product of all the elements except the number itself. Now the product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. So basically they are saying if you are taking product of all the numbers that are on the beginning like 1, 2 and numbers that are on suffix, right, in the ending, that now the product of all these numbers will not be going greater than 32-bit integer, right? That it will have always have a guaranteed storage of 32-bit integer. Okay. And then we have you must write an algorithm that runs in big O of n time and without using any division operation. So now let's quickly understand the problem statement more clearly. Okay. So let me take one example here. So we have 1, 2, 3, 4, 5. This is my array. This is an array and these are my indexes. So we need to find the product of all the other numbers except the number itself. So let me show you one example here. So if I am taking product of all the other numbers except this number itself, so here it will come as all the product of all these numbers. So all the product of all these numbers except one, that will be 120. If I am taking product of all the other numbers except the my number itself, that is 2, so it will be 20 into 3, that is 60. If I'm taking all the product of all the numbers except the number 3, so it will be 40. Okay. And if I'm taking all product of all the numbers except the number itself, so it will be around, that is 5 into 3 into 6. Okay, so that will be 30. Okay, if I'm taking all the numbers here, so it will be 24. So this will be my answer, product of all the numbers except the number itself. Okay, now how we can solve this problem? What can be your approach? So the one approach that can come to everyone's mind, okay, and that is also restricted here, that is that we can take a multiplication of all the numbers, right? We can take a product of all the numbers. So what will be the product of all the numbers? That will be 120, right? And if I divide by each number, right? So if I am dividing this product by each number, so it will be give me 120 here, then divided by 2 will give me 60, then divided by 3 will give me 40, then divided by 4 will give me 30, and then divided by 5 will give me 24. And yes, the answer seems to be correct. This can be one answer. But the issue with this, that it is not applicable. First of all, it is restricted here in the question itself that you can't use division operation here. Okay. But suppose if you are using this method as well, so here we have some edge cases, right, that we need to understand. Even in the example 2, you can understand the edge cases, that is -1, 1, 0, -3, 3. So if I write -1, 1, 0, -3, and 3. And if I'm writing all the indexes 0, 1, 3, 4, okay, these be my indexes. Suppose this is my array. So what should be the answer? Okay, if taking the here, what should be the answer here? So the answer will be, right, all the product of all the numbers, that will be 9 minus 9 here. Okay, and if I'm leaving this, product of all numbers will be plus 9. Sorry, here product of all the numbers will be 0. Here the product of all the numbers will be 0. Here the product of all the numbers will be plus 9. Here again 0, here again 0, because 0 is also the equation. Right. Now if you are applying the same concept, like taking a product, if you are doing here, what you will get as the product, that will be 0. If you divide by, like if you divide 0 divided by minus 1, it will give you 0 itself. 0 divided by 1, 0 itself. And now 0 by 0, that is undefined, like right now that is not defined in mathematical term. Okay, but you want 9 here. Okay, so that is not possible, right? When there are some zeros in it, right, you won't get a correct answer there. Okay, so this approach won't work, right? This will be a failed approach. Now what we can do, now let's see what else we can do here. Again, let's take out the same examples, like 1 2 3 5. I'm just making it here. So I have 1 2 3 4 5 with my indexes 0 1 2 3 4. This is my array. So one possible approach can be that I will take one element, I will consider one element, okay, and then I will find the product of the rest of the numbers, right? So I will find, if I am finding product of all the rest of the numbers, it will give me 120. Okay, that's good. Now what I will do, I will move my pointer, okay, and again I will start from 0. I will start from 0, okay, and I will leave this number only, and again I will take the product of all the rest of, right? So suppose if you are taking product of here, so it will, you will get 1, okay, you will leave 2, okay, and then you will take the product of all the rest number, okay, and that will be 60. So you will get 1 into 60, impossible, right? Then what you will do, you will again move, okay, you will take one number, again you will start from 0, you will take the product of this and this side, and then you will take the product of this side. Okay, so then what you will get, so here you will 2 into 20. Then again what you will do, you will move your pointer, from 2, you will move it here, again you will start taking up till here, and from here to here. Okay, so there always be a left product and right product. So if we are taking this, it will be 6 into 5, right? And you again move, so you will take a product from here till here. So what will be the total product? That will be 24. Okay, and you will simply leave this one, so it will be 24, and again the answer will be same here, that will be 120 60 40 30 and 20. So that is one possible approach that we can apply. So basically what I am saying, that in this approach, our approach 2, because one failed approach, so that I will start from 0, that will start from 0, it will run till the length, or I will say that n, okay, where n equals to array dot length, and then I will take the product as 1. Again I will run a loop that will start from 0 to n, but here there is one catch, that I will write some condition, like if I is equals to j, that means you need to ignore it, continue. Okay, and rest of the cases, what you need to do, you need to simply find the product, that is product equals to product write it like this: product equals to mod into whatever the element is, that is array of 5. Once you completed the product, like if I get the product, I will simply store it after this, like so. Me mention it here, move it. So after this, I will mention. Suppose I am taking one resultant array, thing like this, and I will mention whatever it is. So one of the approach this can, right, approach to, and that is a brute force approach, because what you are doing, you are finding a possibility of multiplication. You are taking, so you are taking each element, right, first one, then this one, then this one, and you are finding product in a complete direction. So if I find out the time complexity of this approach, that will, so this loop, the first loop will run for n times, okay, and this loop will run for n time, okay, both loop will run for n time. So the time complexity here will be big O of n square. So this we need to optimize it, right? We need to work on this time complexity. Okay. So now let's see how we can optimize it. So let's see. So let's apply some optimization here. That will be our approach 3. So how we can think in this direction, that what we need to find. I need to find a product. Okay. Or if I take this example, I need to find a product of all the numbers except the current element, right? Except the current element. So don't you think that this is your something as left portion, this is your right portion? And if somehow I'm maintaining my left portion multiplications, right? So my left product and my right product, so I will be able to solve it. Okay. So what I'm trying to say, so suppose you have taken one array, okay, and now you are you are simply storing all the left product. Okay, that is you are maintaining pre-calculations here, right? So your left product. So for one, what will be the left product? If I take one as an example, that is known as pre-processing. Okay, you have a pre-processed data. So you are maintaining a left product. So what will be the left product for one? Okay, so there is nothing. So can I write it simply as 1? There is nothing completely. Then I will move 2. And what will be the left product for 2? That is only 1. So I will write 1. Now then I will move for 3. What is the left product for 3? Complete left product. That is 2. 2 into 1. Then I will check 4. What is the left for 4? That is 3 into 2 into 1. That is 6. Then I will move to 5. What is the left product for 5? That is 4 into 3 into 12 into 2. That is 24. Into 24. So can I say my left product will be this one? Similarly, can I find the right product? Put this into the center. So this as left product. Similarly, can I find the right product of the elements? So for right, I will start from here. Okay, because I need to maintain the right. For 5, is there any element here on the right side? No element. So can I write it simply as 1? Now for 4, is there any element on the right side? Or what is the right product? That is 5 only. Now for 3, what is the product on right side? 4 into 5, that is 20. Okay. Now for 2, what is the product on right side? that is 20 into 3, 60. Now for 1, what is the product on right side? Can I say that this is 120? Now what I will do, I will simply multiply my left and right product. Okay, this multiply my left and right. So I will, this is an answer. My answer will be the multiplication of this. So 1 into 120, 120, 1 into 60, 60, 2 into 20, 40, 6 into 5, 30, 1 into 24, that 24, and that will be your answer. So we can use pre-processing data here, right? And here, like, so maybe you are struggling with how we need to find these products then. Okay, still we need to maintain a loop? No, right? So suppose here, for left, you got this one, you will simply fill with this one, and now you will multiply 1 with the your current element. Okay, like you are here, next again. So suppose this was my data, 1, 2, 3, 4, 5, and how I am finding my product? I am taking this element, right? So from 1, there is nothing on the left side, so I can simply write it as right. And now I am simply multiplying my left product element, that is 1 into the previous element for this one. So 1 into 1, that will be 1. 1 into 2, 2. 2 into 3, 6. 6 into 4, 24. This is how I am writing my left. So basically here you can see for 5, the multiplication of 4 and 6 will be the answer. For 4, the multiplication of 3 into 2, that will be the answer. For 3, the multiplication of 2 into 1, that will be answer. Similarly, if we calculate the right, here, so for 5, there is nothing on the right side, so I will say simply 1. Now 1 into 5, that will be 5. Now 5 into 4, that will be 20. 20 into 3, 60. 60 into 2, 120. This is how you need to calculate a right and left product. And now, because you are simply multiplying by 1, right, and you are simply moving in one direction, so this will take, your left product will take n times, it will take n time, this will also take n time, right? And after multiplication also, suppose you are taking n time, it will be total 3n times, right? And again these 3n times, the time complexity will be big O of n, because you can simply ignore the constant, time complexity will be big O of n. And your space complexity will also be big O of n. So here you have created this much space for left product, right product, and your answer array, your resultant array. Now let's see if we can further, like this is the correct method, this is the only time and complexity we can get, space complexity we can get. But if we can optimize it a little bit, there is few tweaks we can. So let's quickly check it. So this is my array, and I am writing 1, 3, 4, 5. Index is 0, 1, 2, 3, 4. Okay. Now we need to calculate first product, that is for sure, right? So suppose I am calculating my left product. There is nothing on the left side, so I will put it 1, then 1 into 1, 1, 1 into 2, 3, 6, 6 into 24. And now, instead of creating one more array, right? Instead of creating one more array, can I directly give my answer? So what we can do, we can change here itself. So this is my left product. Okay. What I will do, I will take product with. Okay. And I will simply start from 1. So for this element, there is no right element here. So can I say that there is nothing in the right? So I will simply multiply by my product, that is 1 and 24, that will be. And now what I will do, I will multiply this 1 in the current element, that is 5. So 1 into 5, be 5. Okay, and 5 into 6, that will be 30. So I will simply rewrite it. I will simply change 6 to 30. Okay, so now my product will be 5 to 6, 30. So this will be 30, and here it is 5. Again, what I will do, I will move forward and I will take 4 and I will multiply by 4. So 5 into 4, 20. Okay, and now I will do 20 into 2, that will be 40. Okay, so I will simply change 2 to 40. Again, I will move to the new element. Okay, I will multiply by 3, 20 into 3, that will be 60. Okay, and then I will multiply 60 into 1, that will be 60. So I will simply change 1 to 60. Again, what I will do, I will multiply by next element, that will be 1. Oh, sorry, 2, right? This one, 16 to 2, that is 1. Okay, and then I will multiply 1 to 2, that will be 1. Okay, and I will simply change it. So my left product will change to these answers. That is 120, 60, 40, 30, 24, and that will be your answer. So here you can see we are not creating 3 arrays, right? This we are creating simply this array, and this is my answer array, right? Simple my answer array. I am not creating any extra array to store the numbers. This is for responsible to show the answers, right? So even if we can ignore it because this is my resultant array, this is given in the problem statement that you need to return the array, right? So if we can ignore this array, so the space complexity will be constant. We are not taking any extra space. This is my resultant array, this is my only the answer array, and we are simply doing multiplication only once, right? So we basically stored left product, okay, one by one, and then we are simply taking product of all these, right? So for this 1 into 24, then 5 4, 5 into 6 30, then 5 into 4 product, that is 20 20 30, something like this. Okay, so again here the time complexity is same, that is big O of n. But if you are ignoring, again, if you are ignoring the answer array, resultant array, the space complexity will be big O of n. This will be your answer. So now in the next video, we will see how we can implement these codes. So see you in the next video.